Alright, this is part 4 of our review of radical functions. In this video, we're going to go back to graphing radical functions, such as these. Alright, for number 21, there's nothing in front of the x in here, so I don't need to start with the y values like I sometimes have to. Also, there's no a value, so I don't need a third column. So what I can do is I can go ahead and use the same four x values that I often use. 0, 1, 4, and 9. Alright, because I'm going to get the y values by simply doing the square root of x part of this function. I'm just doing this part. Alright, we'll do the shifting by hand. Alright, so of course when I do the square root of the x values, I get 0, 1, 2, and 3. So let's go ahead and graph these points, but do not connect the dots. We'll leave it as a skeleton. Why did I skip a square? I don't know. So it's 0, 0, 1, 1, 4, 2, and 9, 3. Alright, but now it's time to do those transformations. That's weird. So the transformations are, this -1 is going to take us to the right 1, and this +2 is going to take us up 2. So right 1, up 2. So let's move. Why is this shifting around? Alright, so this is the skeleton right here. So each of these points need to be moved right 1 and up 2. Normally I would change colors, but for some reason every time I change colors, everything moves to the wrong place. So right 1 up 2 would be right here, and then right here, and here, and here. So this is the true graph. Alright, so that's how you graph it. Now let's answer these questions. The starting point is this 1, 2. Alright, is it increasing or decreasing? Well, it's going uphill the entire way from left to right, so that's increasing. The domain is the x values. The x values go from 1 to infinity. Alright, and that needs to be a square bracket. The range, that's the y values. The y values go from 2 to infinity. Alright, is there an absolute max or an absolute min? There is no absolute max because it keeps going up forever. But the absolute min, the lowest value, is 2. Okay, so the absolute min is 2, and absolute max, there is none. What about the end behavior? Okay, as x approaches negative infinity, meaning as we go to the left, what happens to the y values? Well, the y values get closer and closer to this end point, which is at 2. So f of x approaches 2. Now, as x approaches positive infinity, that means as we go towards the right, what happens to the y values? Well, they go up, up, up into the sky. So that means f of x approaches infinity. So that is it for problem number 21. Alright, let's do problem number 22. Now remember, when you have an a value, we need a new y column. When you have a b value, we need a new x column. This problem has both. Alright, we have an a value of 2, and we have a b value of -1. So because of the a value of 2, we're going to create a new y column. So I'm just going to do that. Well, you know what? First of all, let's start off with what the original number should be. This is a square root problem, so we will use the x values that we can take a square root of. We can't take a square root of a negative, but we can take the square root of 0, and without even using a calculator, we know the square root of 1, the square root of 4, the square root of 9, and the square root of 16. So doing the square root of our x values, we get 0, 1, 2, 3, and 4. So let's start with that. So now we're going to make our new y column, and I will just extend these lines to make my new y column. Okay, and my new y column is just going to be the a value times all the y's. So in this case, it's going to be 2y. So 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and 2 times 4 is 8. So this is my new y column, so I can get rid of my old y column, because these are the y values I will now use. Alright, so we've taken care of the a value. Now for the b value. When you have a b value, you make a new x column. So I'm going to just make a new x column like this. Okay, and the new x column is the reciprocal of the b value times all the x's. Now the reciprocal, when I talk about reciprocal, for example, if I had 2/3, the reciprocal would be 3 over 2. But when I'm talking about -1, the reciprocal of -1 is still just -1, because it's like -1 over 1, and then 1 over -1. Either way, it's just -1. Alright, so I'm going to wind up doing -1 times all the x values, but just keep in mind it's really the reciprocal, just in case you have something that's not a 1. Say if that had been a 3, then I would have done 1/3 times all the x values. So watch out for that. Anyway, in this particular case, I'm just multiplying by -1. So -1 times this, -1 times that, -1 times the other thing. Alright, it's basically just turning everything the opposite of what it was. Alright, and again, once you have your new x values, you can throw out your old x values. Alright, so now we've taken care of the a value and the b value. Alright, so just practice our transformations. Remember that a 2 out here in the front would be a vertical stretch by a factor of 2. So by multiplying all these a values, by multiplying all the y values by 2, we have achieved our vertical stretch by a factor of 2. Remember that having a negative right here on the inside is a reflection over the y-axis. And by multiplying all of these x values by -1, we have achieved a reflection over the y-axis. Alright, all the x values are the opposite of what they were. That means they're on the other side of the y-axis. Alright, so we've done both of those transformations. Eventually, we will have to do our final two transformations, which are left 1 and down 1. Maybe I'll just mention that now. This will be left 1, and this means down 1. But we'll do that on the graph. We don't need to do that on the table. So for now, let's go ahead and just plot these points. So we've got 0, 0, -1, 2, -4, 4, and we've got -9, 6. Alright, -16, 8 will not fit on the graph, so we'll have to make do with these. Do not connect these. This is just a skeleton. but we can use this skeleton to help us do the final two transformations, which are left 1, down 1. Okay, so left 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1. Okay, so this will be the final position of my square root curve. And remember that it starts here and then goes in this direction forever. Okay, for some reason it often disappears when I do this. So hopefully it won't disappear now. Okay, it starts here and goes to the left forever. Alright, so that's what your final graph should look like. Now let's answer those little questions. Starting point. So this square root curves have a starting point, which in this case is -1, -1. Is it increasing or decreasing? Remember, when you talk about increasing or decreasing, you read it from left to right. So from left to right, this is going downhill. So that's decreasing. Okay, the domain. The domain is x values, left to right. So this graph goes left forever, and then to the right, it stops at -1. So looking at the x values, it goes from -infinity to -1. And the -1 will be a bracket because the -1 is included in the set. The range is y values. The y values of this graph read from bottom to top. The lowest y value is here at -1. And then the highest y value, well, it goes up forever. So -1 to positive infinity. And it has to be in that order, bottom to top. Is this both -1s? Yeah, I guess it is. So yeah, -1 to positive infinity in that order. Now, does this graph have an absolute max or an absolute min? There is no absolute max because it goes up forever, but it does have an absolute min. When we're talking about max and min, we're talking about y values. So it has a minimum at -1. Okay, and end behavior. End behavior is all about what's going on the left end and what's going on the right end of the graph. Okay, and this means what are the x values doing, and this means what are the y values doing. So let's analyze the graph. So let's look at the left end. Okay, here's the left end over here. What are the x values doing? So looking at the x values, all right, see this arrow? The x values are left, right. Is this left or is it right? It's to the left, so that means the x values are going towards -infinity. So some students will look at this and say, well, it's going up, so shouldn't that be positive infinity? Well, as soon as you say the word up, you're talking about y values. Y values go up and down. X values don't care about up and down. X values only go left and right. And so because this is going to the left, that means the x values are going towards -infinity. Now we'll talk about the y values. The y values are up and down. So looking at this arrow, is this up or down? Yeah, this is going up, so that's your positive infinity. So -infinity, as the x values go towards -infinity, the y values go towards positive infinity. Okay, now let's look at the right hand end of the graph. Okay, here's the right hand end right here. So let's talk about the x values and the y values. Okay, looking at this end right here, notice it's not an arrow, it's just a point. So there's no infinity happening here. What is the x value of this point? It is -1. Okay. What is the y value of this point? It is also -1. So as the x values approach -1, the y values also approach -1. So there's your end behavior. And that is it for problem number 22, the graph and the analysis. Booyah. Alright, for number 23, we're supposed to write the equation of the radical with domain from 1 to infinity and a range of 7 to infinity. Okay, so if you picture a normal, x and y axis, okay, usually a square root function will do like this. But in this case, the domain is supposed to be from 1 to infinity. So that means it has to start off to the right by 1. And the range, alright, because domain is x value, so it has to go over 1 on the x-axis. The range has to start off at 7. So let's see, 1, 2, 3, 4, 5, 6, 7. Okay, so that means the starting point has to be way up here. And then it's going from there. Okay, so imagine that the starting point is here. It's over 1 to the right and up 7. Okay, so in fact, let me write that down. So if we know it's got to be right 1 and up 7. So as we go ahead and write that graph, that function, to go right 1, we need the square root of x minus 1. And to go up 7, I need a plus 7 on the end. So this would be the answer to number 23. Now, number 24 is a cube root problem. So we need to use x values that we can easily take the cube root of. For example, 0 and 1 and 8 and -1 and -8. Alright, these are perfect cubes, so I can easily do the cube root. So we're doing the cube root of all the x's right here. The cube root of -8 is -2. The cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. Alright, so this is the parent function, if you will. So, we have an a value, so therefore I will need a new y column. We have a b value of -1, so therefore I will need a new x column. Okay, so let's see, got to move over a bit. So for the new y column, it's going to be like this. So I'm going to just put in a new y column over here. Okay, and for the new y column, we always multiply the a value times the y values. So in this case, the a value is -4. So I'm going to do -4 times all the y values. So I'm just going to multiply all of these by -4. So that's going to make +8 and +4 and 0 and -4 and -8. Now, because there is a b value, I need to make a new x column. So I'll just make my new x column over here. By the way, when I make a new y column, I throw out the old y's. So here comes my new x column. And I make my new x column by doing the reciprocal of the b value times all the x's. All right, 1 over b means the reciprocal of b. Now the reciprocal of -1, if I do -1 and I put 1 over -1, that's still -1. So I'm going to wind up multiplying -1 times all the x values. But please understand, I'm not just multiplying by the b value, I'm multiplying by the reciprocal of the b value. If the b value were 2/3, I would multiply by 3 over 2. Anyways, if I multiply all these by -1, it's just going to make them the opposite of what they are. So this is going to be 8 and 1 and 0 and -1 and -8. So these are my new x values. So the old x values go bye-bye. So I'm going to use these x values and these y values for my skeleton. Okay, so 8, 8. And then I've got 1, 4. And 0, 0. And -1, -4. And -8, -8. Okay, so this is the skeleton. I am not going to connect these values, but it shows me the shape of my graph is going to be making this sort of a wave. But what we haven't done yet is we have not done the up, down, left, right shifting. So this -1 means we are going to go to the right one. Okay, so the opposite of the way that you would think. This is our up-down number, and it works just like you would think, so this will be down 2. So right 1, down 2. So I will move each one of these points right 1 and down 2. Right 1, down 2. Right 1, down 2. Right 1, down 2. Right 1, down 2. So these pink values are the real values. Okay, so your graph should look something like this. And now we can answer all those little questions. Starting point, there's no starting point for a cubic function, so I'm just going to put none. Increasing or decreasing. Well, remember, as you read increasing and decreasing, you have to read the graph from left to right. And from left to right, this is just always going up, 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 up. So that's increasing. Domain. The domain and range for a cubic function will always be -infinity to +infinity. The domain is the x values, and this graph goes left and right forever. And the range is y values, and the y values go down and up forever. So that's why -infinity to +infinity. Absolute max, absolute min, we have none of those. Because, like I said, it goes down forever, thus no absolute min, and it goes up forever, so there will be no absolute max. End behavior. End behavior is all about what is happening on the left end of the graph, and then what is happening on the right end of the graph. And specifically, on the left end, what are the x values doing and what are the y values doing? And then same thing on the right. So we're looking at what about the x values and the y values. So first let's start with the left end. So the left end is right here. So look at this arrow. This arrow tells me that we're dealing with infinities, okay? But we are talking about the x's and the y's. So, x values go left and right. So is this arrow going left or right? You see it's going to the left. So that means the x values are approaching negative infinity. Now let's talk about the y values. Y values go down and up. So is this arrow going down or up? Yeah, it's going down. So that's also negative infinity. Okay, so that's your end behavior. As the x values go towards negative infinity, the y values go towards negative infinity. Now let's look at the right end of the graph. All right, the right end of the graph is over here. Again, you see this arrow. These are going to be infinities. So let's talk about the x's and the y's. X's go left, right. Is this going to the left or to the right? It's going to the right, so that's positive infinity. Now y values go down and up. Is this going down or up? It's going up, so that's also positive infinity. So, in positive infinity, positive infinity. So as the x values approach positive infinity, the y values approach positive infinity. And that is it for problem number 24.